We are going to look further into similarity today. Today we're going to look at similarity in overlapping triangles. And when our triangles are overlapping, sometimes this can make things more difficult because it's not as clear of a picture and we have to unwrap or untangle those triangles. So when we look here, it's always good when we are given similarity statements, just like with congruency. We like to know which sides and which angles are corresponding. Because I have my similarity statement, I know that segment DO corresponds to DY, so those are making a ratio. OG corresponds to YO, so that makes another congruent ratio. And then DG corresponds to DO, so that makes another congruent ratio. So now I have to look at my diagram. DO, I'm given DO and my diagram is 10. DY is 4. OG, we don't know anything about OG, so that's still just OG. YO, don't know anything about YO, so that's not helping us. DG, so in my diagram, DG from start to finish is represented by X. DO is 10. So out of those three pieces, these are the two that I'm going to use to set up my proportion. I'm not going to use the middle one because I don't know anything about OG or YO. We cross multiply. 100 equals 4x. Since we're multiplying by 4, we divide by 4. And we find that x is going to be equal to 25. This one was nice because I was given my similarity statement. The next one is not going to be as easy. And this is going to be a big question for your quiz and test. We have these overlapping triangles. The first thing that we must do is we must redraw the triangles. We need to untangle them, and you'll have to untangle them and redraw them on your quizzes and your test. So to do this, we look for similarities. I see that I have a right angle here, and I have a right angle here. That's going to be my starting point. So I'm going to draw 3 triangles, and when I draw them, I have to draw them in corresponding order. Because if I don't draw them in corresponding order, everything is going to get messed up. I'm not going to be able to see those easy ratios. I'm not going to be able to see my similarity statement. So whenever we are the ones drawing the pictures, we're going to draw them all so they are in corresponding order. So because it's a right angle, all right angles have to be in the top right corner. So this first one, I'm going to write as triangle ABC. I didn't change anything. That's what I was given, triangle A, triangle B, triangle C. Now they're sharing angles. Angle A, I'm going to mark each angle differently. So I'm going to give angle A a marker, and I'm going to give angle C a marker. So this is where angle A is. This is where angle C is. I have to draw those angles in the same corresponding location. Again, the first one's the easy one, the one that we're given, ABC. Now I'm going to move on to a different one. I know the right angle has to be here, so I look for another right angle. I have another right angle here at D. So this letter right here is going to be D. And I'm going to either choose the triangle over here on the left or the triangle on the right. Doesn't matter which one you start with. Let's say I start with the one over here on the left. I see this angle marker. This angle marker has to go in the same corresponding location that we drew in the first one. In the first one, I drew angle A over here. So angle A. So I'm going to go from angle A to angle D, which means angle B is only left with to go down there. I have this other angle triangle over here. Again, that right angle is at D. When I look over here, the marker that they share is this double marker. That double marker has to go in the same spot that we listed it the first time. So this has to be C. So angle CD, the B is going to go over here this time. So the first thing you do is you start with making sure that all right angles are in the same spot. Then based on the big triangle, you line up the angles in corresponding locations. So we can go ahead and fill in our information. AB, from up in our diagram we have, is X. BC, according to our diagram, is Z. AC is from start to finish, which is going to give us 10. AD in our diagram is given as 8, DB is Y, AB is X. Again, all I'm doing is looking at the big diagram that was provided. Segment BD is Y, segment DC is 2, and BC is Z. So I have redrawn my triangle so they are in corresponding order, which makes my similarity statement really easy. Based on this, I start with triangle ABC. So since I went ABC, then that's similar to ADB, which is going to be similar to BDC. So that is my similarity statement showing me all 3 triangles that are similar to each other. And then from there we can go ahead and set up our proportions and use those to solve. So if I look at the first 2, x and 8 correspond, so I can put x over 8 is equal to z over y. Again, I'm looking at corresponding locations, 10 and x. Because we drew our diagrams in corresponding order, I know these are the pieces that are going to match up. When I look, I need to pick the 2 that are only going to give me one variable. I cross multiply those, so that gives me x times x, which is x squared. 8 times 10 is 80. We square root 80, and x is going to be about 8.9. So now we have x. We still need to solve for y and z. So I look at the next one. 8 corresponds to y, so 8 over y, y and 2, y over 2, x to z. Again, you're going to choose the 2 that are going to leave you with only one variable so that you can solve. So 8 times 2 gives us 16 equals y squared. We square roots. Y is equal to 4. And the last one, we compared the first 2, the last 2. Now we're going to compare the first triangle and the last triangle. So x corresponds to y, so we have x over y. Z corresponds to 2, so z over 2. And 10 corresponds to z, 10 over z. We are going to choose those 2, so z squared equals 20. Square root of 20, we get z is going to be about 4.5. All right, so the hardest part is unwrapping the triangles and untangling where they go. You just have to make sure that you're getting everything in corresponding order. All right, we do have one more for today. We have the coordinates of triangle ABC and the coordinates of triangle LMN. Are the 2 triangles similar? If they are, provide mathematical proof, write a similarity statement, the scale factor, and an explanation of why they are similar. If not, provide mathematical proof and explain why they are not. So let's go ahead and start by plotting our points. So A is at 10, 4. B is at negative 8, 6. C is at 2, 0. It's better if you use a straight edge. There's our first triangle. And then we have L is at 5, 2. Negative 4, 3 is M. And 1, 0 is N. So we want to determine whether or not these are similar triangles. The easiest, there are lots and lots and lots of, not lots and lots of ways, but there are multiple ways. We're going to look at 2 different ways to prove this, but we're only going to show the easiest one today. The easiest way to show whether or not 2 triangles are similar is to show whether or not they are a dilation. So we're going way back to the beginning of the unit, and we're going to see if they are a dilation or not. So if I look at my coordinates, if I go from coordinate A is at 10, 4, is there a number I can multiply that by to get, not B, to get the coordinates of L, which are at 5, 2? Is there a relationship between those? Well, 5 or 10 to 5, 4 to 2. I'm cutting each of those in half, so my scale factor here is 1/2. If they are all multiplied by that same scale factor every single time, it's a dilation. So let's see. B is at negative 8, 6. We want it to get to M, which is at a negative 4, 3. Negative 8 to negative 4. 6 to 3, yep. If I multiply each of those coordinates by 1/2, I get my new 1. And the last one, C, is at 2, 0. And I want to get it to N, which is at 1, 0. And again, it has the same scale factor. So we can say, yes, triangle ABC is similar to triangle LMN because triangle ABC is dilated by a scale factor of 1/2 to get triangle LMN, and dilations create similar figures. We will talk about another way to prove triangles similar in the coordinate grid, but the easiest way to do it is to show whether or not they are dilations. You do have to show mathematical support, which is what we did over here to the left, and then explain your answer with the similarity statement. You have to tell me what the scale factor is, and the key that we knew that it was going to be similar is because we knew it was going to be a dilation. All right, that is the conclusion of this video.